Okay, business owners looking for ways to increase sales. It is known that the percent of businesses that use email marketing to help grow sales is 52%. Business owner believes that the percent of businesses that use email marketing to help grow sales has increased. So a percent, you can easily write that as a proportion. This business owner thinks that it's greater than 0.52. That's your alternative hypothesis. Okay, the alternative is the one you're trying to test. So the null hypothesis, we assume that it's still the same as what it's always been, 0.52. The alternative, they're testing to see if it's greater than 0.52. Let's see what else we got here. And then use the following information. Use the information obtained for the test statistic. Oh, do we get to have a table here? Oh, they're gonna make it. Okay, so the p-value is, without giving a full definition, I guess the p-value is just that area beyond the test statistic. So they got a test statistic of z equals 0.97. So this is the p-value of your test because it's a right-tailed test. If it was a left-tailed test, I'd just draw it over here, draw that shaded area. The p-value is that shaded area that's beyond your test statistic. Okay, so what's the p-value conclusion for this hypothesis test? We said it's a right-tailed test. Let's do that. The significance level, I don't know why they make us drag this. Where is it? Significance level is 0.01. Oh, right there, 0.01. And the p-value is going to be determined by that z-score of 0.97. So the test statistic is 0.97 right here. So it tells you that red shaded area that we were looking for is 0.166. That's your p-value. 0.166. We failed to reject the null hypothesis, okay? Because a p-value has to be less than alpha. Okay, p-value has to be less than this alpha in order to reject the null hypothesis. Our p-value of 0.166 is greater than that alpha of 0.01. So we should fail to reject the null hypothesis. Okay, because a p-value is the probability that that you get such a test statistic given the null. It's kind of like a probability of the null hypothesis. If the p-value is high, you can't reject the null hypothesis because the null hypothesis is likely. It's likely that H0 p equals 0.52. And this is a loose definition, okay? This isn't the exact definition of a p-value. But if the p-value is low, then the null hypothesis is unlikely. Our p-value was high compared to our critical value. Sorry, our p-value is high compared to the alpha they gave us. That's what you always want to compare it to. So since it's high, we fail to reject the null hypothesis. Okay, I think that's it for that question.